All right, let's dive into something that's literally everywhere, but you probably barely touched on it in school. We're talking about the most common state of matter in the entire universe. Yeah, I'm talking about plasma. It's this electric secret that basically runs the whole cosmos.
So let me ask you something. What is stars, like our sun, a bolt of lightning, and one of those glowing neon signs at a diner? What could they possibly have in common? Well, the answer is plasma. And it's not just some random connection, it's the actual stuff that makes up all three of those things. And honestly, once you get this, it's going to completely change how you look at, well, everything.
Okay, so to really wrap our heads around what plasma is, we got to take a quick step back to the basics. Let's talk about the states of matter. And yeah, I said four.
You know the drill from science class, right? You've got your solids like a block of ice, you add some energy, some heat, and it melts into a liquid. Add even more energy, it boils and turns into a gas, right? The particles are just moving faster and spreading out. But what happens if you just keep going? What if you crank up the energy on that gas to an extreme level? What's next? That's when you get plasma. People call it a superheated gas, but that's kind of underselling it. The really wild part is that the energy gets so intense, it literally rips the atoms apart. It strips the electrons right off, leaving behind these positively charged things called ions. So you don't have a bunch of neutral atoms anymore. What you have is this buzzing electric soup of charged particles.
Think of it like a cosmic recipe. You start with your ingredient, a normal gas, where all the atoms are neutral and balanced. Then you turn up the heat big time. You add a massive blast of energy, either crazy high temperatures or a powerful jolt of electricity. That energy is so strong it just knocks the electrons right out of their cozy orbits. And voila, you get plasma, a big ol' mix of those freed up electrons and the positively charged ions they left behind.
So now we know what plasma is, but where do we find this stuff? The short answer, pretty much everywhere.
And finding it is all about looking for its special tricks. See, because it's made of all those charged particles, plasma acts in ways a normal gas just can't. For one, it can conduct electricity. Think about lightning. It also reacts to magnetic fields, which is super important. And of course, the most obvious one, it glows.
And when you look up at the night sky, you're basically looking at a universe filled with plasma. Our sun, every single star you see, they're just giant churning balls of plasma. Those incredible northern lights, the auroras, that's plasma too, lighting up when particles from the sun hit our atmosphere. Even those huge, beautiful clouds of gas and dust between the stars, the nebulae, yep, that's plasma. But it's not just way out in space. We've actually figured out how to use it right here on Earth. A lightning strike? That's just a massive natural plasma channel zapping through the air. Every fluorescent light bulb, every neon sign, works by turning a gas inside a tube into a glowing plasma. We even use these insanely hot, focused plasma torches to slice right through solid steel. Wild, right?
But this whole plasma thing goes way beyond just making pretty lights or cutting metal. The very same properties that make stars shine, well, they might just hold the key to the future of energy for all of us here on Earth. Okay, remember how I said plasma is affected by magnetic fields? Well, that's the absolute key. You can't exactly hold something as hot as a star in a physical container. It would just vaporize. But you can contain superheated plasma inside an invisible magnetic bottle. This lets scientists control it without it ever touching a thing. And why on earth would we want to do that? Well, for the ultimate prize, fusion energy. Scientists are building these incredible machines that use huge, powerful magnets to squeeze and heat plasma until it gets unbelievably hot, hot enough to force atoms to fuse together. They are literally trying to build a tiny star here on Earth. I mean, just think about that. If they can crack this, it could mean almost limitless, clean energy for everyone. So this brings us back to one of plasma's most famous features, right? The glow. Why does it happen? Well, it's pretty simple, actually. When one of those free-floating electrons finds an ion and they recombine, they have to release a little burst of energy, and they do it in the form of light. The color of that light all depends on what kind of gas you started with. That's exactly why neon signs glow that classic reddish-orange, but if you use argon gas, you get that cool blue color. All right, let's just pull this all together for a second. When you go from solid to liquid to gas, all you're really doing is giving the particles more energy so they can move around more freely. But that jump from gas to plasma, that's a whole different ballgame.
It's not just about more energy, it's a fundamental change to the particles themselves. You're transforming them from neutral little atoms into a sea of electrical charges. It's the biggest leap of them all. Okay, I saved the most absolutely mind-blowing fact for last. Are you ready for this? More than 99%, let me say that again, over 99% of all the visible matter in the entire universe is plasma. Just let that sink in for a second. Everything we think of as normal, the solid ground we're standing on, the liquid water we drink, the gas we breathe, all of that, it adds up to less than 1% of the universe. The stuff we learn about in school, solids, liquids, and gases, they're actually the cosmic weirdos. They're just these tiny, rare, cool pockets in a universe that is, by and large, electric and glowing. And that really leaves us with one final big question. We live our whole lives on this little rocky planet where neutral matter is the rule. But if the universe is so overwhelmingly electric, and we've been kind of overlooking its most common state of matter, what other massive fundamental secrets is the universe just waiting for us to discover?